especially for some of the clicks.
But it's the same phone. The screen protector, yeah, my screen protector is just different, so that's why.
All right, so we are Team Tango, and we are here to present our product OPINE, which is the Overdose Prevention Information Network Exchange. No, no, go back. That's a good one, no. So in 2016, Indiana ranked 14 in opioid overdose deaths per capita, which equates to 1,245 opioid deaths. There were 3,442,443 opioid prescriptions written, with roughly 20,000 dispersed. This is typically caused by easy access to prescriptions like pill mills, family and friends access, and injury. You can go ahead. So this chart represents painkiller prescriptions per 100 people. As you'll see, this green square over here indicates Indiana, which varies more towards the highest. That's 109. So there are 109 active painkiller prescriptions per 100 people. Think about that for a second. So most people think that the issue is focused more on more social despaired entities, and in all reality it's not. It's dispersed pretty widely. What you see here are the top 5 counties in Indiana in 2016 with opioid overdose deaths, with Marion County in the center being at the top with 161. So our problem solution is a Narcan tracking application and patient communication. So Narcan is a life-saving medication that is administered on scene by a first responder. It rejects opioid off of the brain receptors and instantly sends somebody into withdrawal, saving their lives. What we intend to do is to take this application, integrate it into the first responders workflow, track Narcan administration on site, and then through a camera, scan the user's ID, absorb and aggregate their data, de-identified and specific. We will then use geospatial on the phone to track the location, and ideally take this information and relay it to the receiving hospital or entity, creating communication between previously siloed entities such as hospitals.
So that was kind of step 1 of our application. Step 2, the second outcome, is data analytics. So I have the quote up there. We have the quote up there by Tim O'Reilly showing that information is more important than software. This will work by doing the aggregated data on the back end, all the things that he just mentioned, like the demographic data, where it was administered, things like that. An analyst can then go in and aggregate that data and kind of make reports out of it. So this doesn't have to be somebody at the hospital. This can be somebody in the Department of Public Health, somebody at maybe the police station, somebody in the governor's office. They'll export it, utilize it, and then work on public health initiatives for various things based on gender, ethnicity. You can go ahead and hit next. So relating back to our problem space, why is it needed? It's kind of a cycle, right? So there's minimal collection efforts, which lead to a lack of analytic support, which leads to kind of siloed departments and information, which we identified in our interviews. Unwavering growth of overdoses. The opioid epidemic obviously is still here today. Hidden population, social stigma, which then makes people not want to collect data on it, and so forth. OPINE is a social computing application, mostly because it's got the system functionality of active communication between the hospital staff and the EMT, and then it allows for alerts on oncoming patients, access to previous medical records, and provides a preparation time for hospitals. Down here we see that we get the information for the first responders, like allergies, active medication, and medication history. This allows people to see their information as they need it, sort of right in front of them, as opposed to having to do guesswork and go back and look later. We realized that we'd have multiple requirements for this application that revolved around it being simple. We wanted it to be simple, low cognitive load. These are high stressful situations and low computing devices that they're going to be running on. People's cell phones, people's computers in the ambulance, etc.
All right, so for this, what we wanted to do was I created a couple wireframes here from a Windows device. So EMTs have these kinds of screens available to them. They have computers inside of their ambulances. Doctors have access to these. So you have a basic access where you can take a screen and take a video and take their ID in front of that and have it record it. And it takes that information, puts it up on the screen in a way that's usable and understandable to them, and keeps it there. So this is just the basic sketches that we originally had. And from our evaluation results, the two that are kind of the most important is number 3 and number 4 here, which is how and where should first responders enter that Narcan data, and the navigation that they have to reflect, and that current accuracy and workflows for the providers. So in order to do that, I created this interactive prototype that was for the EMTs in this particular instance. So as quickly as possible, they need to be able to put that information in there. So when we create this information, we log in, we have the EMT, the doctor log in. They can scan that particular icon, their ID associated with it. And then it pulls up that information about that patient, creating this living document about the patient. And because this is EMTs and it's quick and efficient, they have where they can quickly enter that information and have it viewable to them. Or if they need to know about their allergies or active medications before that time is up, before when they're actually engaging with the patient, they can quickly view it. And then when they send that information, it goes to a data source that they can actually view this from. So in this case, this is the Windows platform that showcases that information. And right here, you have a list of every time that the ID was scanned, and every time someone put a piece of information there, it allows them that ability to see that. So what I did was I created a short video kind of just showcasing this process. So in this case, what you have is where the user puts the EMT can put their ID over top of it, and they can see it. It pulls that information up. And then what it does is it sends it to a cloud kind of management system where it automatically updates to the EMT's computers, to doctors' computers that are going to the emergency room. And then that particular doctor who's off-site, off somewhere different, can see that person's information before they come to an emergency room. So you're closing that together. All that data comes together in a way that people can view and access. And that data then is stored in a third-party application that people can actually engage with and interact with. So if we need to do data visualization, it takes information on geolocations where it was scanned. The particular things, their allergies, everything that was associated with that patient in a way that people can use it and interact with it. So that's kind of the general idea of our application, and where we're looking to head for in the future, bringing together all these communities in a way that makes sense where they can communicate and data collect for them. So that's our presentation. Do we have any questions? Yes.
What's the ID that is scanned? Like, what type of ID?
Okay, can I answer? Yeah. Yeah, so the reason the ID is a thing is because of HIPAA compliance. We originally, like in my original wireframes that I had where we had like first name, last name, that's not HIPAA compliant. So what we wanted to do is we wanted to create something that would actually, like, when you scan it, it creates an identifier for the people, but it won't it'll still have HIPAA compliance and it'll actually work with it.
It's the physical ID. So when
Oh, I'm sorry. Okay, thank you. I apologize.
The
Indiana driver's license has a barcode on the back.
They all do though, but so you're collecting the metadata off of the actual card itself, which would be de-identified at that point unless they were specifically built into the system, in which case it would merge with the existing record. Sorry.
So I apologize.
No, it's okay, it's okay.
That's a good answer, though.
I can handle that better, I'm sorry. Okay, so slick presentation. I believe opioids abuse is a problem, right? Like, you've convinced me of that. Your demo looked really slick, but why is collecting data about Narcan usage useful? That was less explained. You tried, like, you had that, like, the circular chart, but it was not getting, like, why is understanding where Narcan is being administered useful and to who is useful? Like, who wants to use this data? What is it being used for?
Do you mind? So that's what makes this challenging in general, because originally the concept was built around the idea of tracking for public health initiatives and data analytics and not social computing. The idea would be to collect the data purely to obtain geospatial, gender, ethnicity. Once you have this information analytically in like our statistical software, you can take a look at prevalence, incidence, how much Narcan's been administered, to what dosage, what's the population that's experiencing overdoses, and then apply that to public health initiatives to target treatment, such as improved infrastructure, therapeutic connections, needle syringe exchange programs. So holistically, the idea would be to take this data for a public health perspective and then apply initiatives to improve on that infrastructure.
Right, then in your framing, you should have explained that, right? Like in your framing, you should have just said like opioid crisis is a problem, like that's what's happening. Like yes, that's part of the tragedy, but that's actually not the problem that you're solving. What you're solving is you're giving additional information to public health officials who need additional information to make better programs. So then say that to make it clear, otherwise it's kind of like there's a gap missing between your solution and the problem that you've identified.
I mean, I would say that the analytics component of that satisfies that need. It may not have been expounded upon to that extent, but the data...
It's unclear in your presentation that that's what you were doing, that you were creating tools for public health officials.
Sure.
I may be the only one who is confused, but I doubt that.
Yeah, I mean, it was addressed for social computing when it was created initially for analytics. So there was an adaptation for that.
I don't understand your response. What do you mean?
Like the initial idea was founded and kind of exists roughly in Baltimore. The idea is that it was an analytical based component used by their public health department. The issue with their structure is that it didn't collect any data that was pertinent outside of Narcan administration specifically. So you weren't identifying population. For the sake of this program, you know, we wanted to adapt it and morph it into that. So I think, you know, it's challenging to meet both of those requirements well. So I don't necessarily disagree with, you know, what you're saying. I think that it would in the long run accomplish that. Both. That's just me.
Thank you guys.